All right, so after you guys have created those tables, the sine, cosine, tangent table, and then also the charts that show your angles, there's only one other thing that I really need you to know in order to be able to kind of go around the unit circle and not have to memorize that whole thing. And that's the acronym All Students Take Classes. So that stands for, the A stands for all trig functions are positive in the first quadrant. In the second quadrant, only the sine functions are positive. Third, only the tangent functions are positive. And fourth, only the cosine functions are positive. So let's take that and try a couple problems that aren't just in the first quadrant out. So first example, I'm going to take a look at these three examples first. And you guys should have this document online to check out. So the first example is the sine of 7 pi over 4. So the first thing we need to do is we need to look at our table and we need to find the sine of any pi over 4 angle. So it doesn't matter if it's 1 pi over 4, 3 pi over 4, 5, and 7 pi over 4. Really all we need is any of the pi over 4s, and then we'll figure out whether it's positive or negative later. So the sine of pi over 4 is radical 2 over 2. The next step we do is we take a look at our radian measure chart and we try and find out what quadrant is the 7 pi over 4 in. And when we look around our quadrants, we find that it's in the fourth quadrant right here. And then finally, we're going to go down to our unit circle added onto that to decide whether or not sine is positive or negative in that quadrant. So we look at the fourth quadrant, and cosine is the only thing positive, which would mean the sine would have to be negative. So we would have our answers negative rad 2 over 2. All right, let's try that same thing with the next thing. So remember, it's 3 steps. You start by finding the value. Then we find the quadrant this angle falls in, and then we determine whether it's a positive or negative value for that trig function. So for the tangent of 7 pi over 6, we're going to look up the pi over 6, find tan. We find that it is 1 over rad 3 or rad 3 over 3, whichever one you want to use is fine with me. Then we're going to find the quadrant it falls in, so 7 pi over 6. We find that on our pi over 6 chart when we see that it's in the third quadrant. And when we look down at our unit circle, we see the third quadrant has tangents being positive. So we're going to keep this as a positive answer, and we're all set. All right, last example. If you want, give it a quick pause, try the example, and then hit play again to check it out. All right, so the cosine of 2 pi over 3. We find the cosine of pi over 3 first by going to our chart. So the cosine of pi over 3 is 1/2. Then we find where does 2 pi over 3 fall, which is in our second quadrant. And then when I look at my chart, my unit circle below, I see that sine is the only thing positive in the second quadrant. So that means that this is going to have to be a negative 1/2. So the cosine of 2 pi over 3 is negative 1/2. So if you guys can follow those 3 steps whenever you have those pi over 3, 4, or 6 angles, it takes a lot of the guesswork out of, is it positive, is it negative, did I create the unit circle correctly? If you could follow these 3 steps with these 3 charts that we've been making this week. All right, one thing is sometimes we do deal with some angles we could find the exact values of that are not in our chart, and that's with pi over 2, 3 pi over 2, and pi. Now these angles, I'm going to defer back to our unit circle for. So I'm going to add a few things to our unit circle here. First thing I'm going to add is the radian measures. So we know that the 0 radians is down right at the x-axis in the first quadrant. Pi over 2, or 90 degrees, is up top. Pi is to the left. 3 pi over 2 is at the bottom. And then 2 pi is all the way over here on the right, back where 0 was. Now, the other thing that's important here is the actual coordinate points on the unit circle. So for each point where the circle meets the axes, we're going to label as, remember, it's a unit circle. It's 1 away. So we're going to the right 1 and then up and down 0. So the coordinate point is 1, 0. Up top, it's 0, 1. To the left, it's negative 1, 0. And at the bottom, it's 0, negative 1. Okay, so to work with the unit circle, we also have to remember these coordinates that we're used to being x, y, and with the unit circle, it aligns with the cosine of the angle, comma, the sine of the angle. And I like to remember this order by the fact that it's alphabetical. So x comes before y, c would come before s with cosine and sine. So the x corresponds to the cosine, the y corresponds to the sine value. So our first example, we have the sine of pi over 2. So we're going to find pi over 2 on the unit circle and look at the coordinates. So the answer is going to be either 0 or 1. And in order to do that, we just need to know that the sine is our y coordinate. So our answer in this case will be 1. For the cosine of 3 pi over 2, we'll find that on our unit circle. We have the coordinate 0, -1, and cosine's x, so our answer is 0. Now the only time this gets a little bit tricky is when we're dealing with tangent, because there is no tangent point, but what we do know is that the tangent is the same as the sine over the cosine. So we just have to find the sine of pi, which is 0, and the cosine of pi, which is -1, and divide them. And 0 divided by -1 is 0, so we're going to have the tangent of pi is equal to 0.